Rupesh Kumar from Government Polytechnic Narayankhed. Today I want to share some information regarding the combinational logic circuits. Topic: circuit and function of half adder. Already we learned about the number systems and its concepts, as well as digital logic families and different logic families, comparisons, IC numbers also. Today we will learn about the topics that combinational logic circuit, function of half adder, etc. Combinational logic circuits and function of half adder, etc. Recap: logic gates are the decision making devices. Logic gates are the basic building blocks of the logic circuits. Name some logic gates. Here, logic gates, we think that decision making devices here, and they are also the basic building blocks of logic circuits. Basic building blocks of logic circuits. Here I am naming some logic circuits. They are AND gate, OR gate, NOT gate, NAND gate. Here the mistake is there, NOR gate, that one, and XOR gate. These are the different logic gates which we encounter in our previous classes. AND gate, OR gate, NOT gate, NAND gate, NOR gate, and XOR gate. Once again repeating, logic gates are the decision making devices. Logic gates are the basic building blocks of logic circuits. Name some logic gates: AND gates, OR gates, NOT gates, NAND gates, NOR gates, XOR gates. Okay. Now going to our topic, that combinational logic circuits. In this circuit, its output depends only on present inputs. Combinational circuit is a circuit which its output depends only on present inputs. Logic gates are the basic building blocks of combinational logic circuits. Once again repeating, definition of combinational circuit. The combinational circuit is a circuit which output depends only on present inputs. Output depends only on present inputs. Logic gates are the basic building blocks of combinational circuits. Logic gates are the basic building blocks of combinational circuit. Book is where? Half adder. Examples of these circuits are half adder, full adder, multiplexer, demultiplexer, decoder, encoder, etc. Examples of combinational logic circuits are half adder, full adder, multiplexer, decoder, demultiplexer, and encoder, etc. Now we are going for the half adder. Half adder, we know that it has two inputs and two outputs. It adds two bits, that is binary digits, and produces two outputs, sum and carry. Sum and carry. Half adder has two inputs and two outputs. It adds two bits, binary digits, and produces two outputs, sum and carry. Produces two outputs, sum and carry. Next, full adder. It has three inputs and two outputs, and it adds three bits and produces two outputs, namely sum and carry. Full adder, it has three inputs and two outputs. It adds three bits and produces sum and carry outputs, and produces sum and carry outputs. Now multiplexer. A digital circuit that sends data from any one of the many lines in a single line, many lines onto a single line. A digital circuit that sends data from any one of many lines to a single line. Different data will present at the multiple inputs. Different data will be present at the multiple inputs. Out of these multiple inputs, one is selected and sent to the output line. Out of these multiple inputs, one is selected and sent to the output line. Out of these multiple inputs, one is selected and sent to the output line. Decoder. It converts binary data into other form such as decimal, octal and hexadecimal. It converts binary data into other form such as decimal, octal and hexadecimal, etc. Next, arithmetic circuit. The circuit which performs the arithmetic operations like addition, subtraction, multiplication and division is nothing but the arithmetic circuit. Examples of arithmetic circuits are half adder, half subtractor, full adder, full subtractor, etc. The circuit which performs the arithmetic operations like addition, subtraction, multiplication, division, etc. Example of arithmetic circuits are half adder, full adder, half subtractor, full subtractor. Once again repeating these definitions of different combinational logic circuit. Most important, please note down the definitions of the respective devices here or circuits here. First one is half adder. It has two inputs and two outputs. It adds two bits, that is binary digits, and produces sum and carry. It has two inputs and two outputs. It adds two bits, that is binary digits, and produces sum and carry. Next, full adder. It has three inputs and two outputs. It adds three bits and produces sum and carry outputs. It adds three bits and produces sum and carry outputs. It adds three bits and produces sum and carry outputs. One minute. Please note down the half adder definition. It adds two bits, that is binary digits, and produces sum and carry. See, the major difference between half adder and full adder is, in half adder it takes the two inputs, and full adder it takes the two outputs. Three inputs. And similarity is, half adder has two outputs, and full adder has two outputs. The outputs names are sum, carry. Full adder, write down this one. It has three inputs and two outputs. It adds three bits and produces sum and carry outputs. Okay. Next one, multiplexer. Please write the definition. A digital circuit that can send data from any one of the many lines onto a single line. A digital circuit that sends data from any one of many lines to a single line. A digital circuit that sends data from any one of many lines to a single line. Different data will be present at the multiple inputs. Out of these multiple inputs, one is selected and sends to the output line. Out of these multiple inputs, one is selected and sends to the output line. Now decoder, it converts binary data into other forms such as decimal, octal, hexadecimal, etc. Decoder, it converts binary data into other forms such as decimal, hexadecimal, octal, etc. Decimal, octal, hexadecimal, etc. Arithmetic circuit, the circuit which performs the arithmetic operations like addition, subtraction, multiplication, division. The circuit which performs the arithmetic operations like addition, subtraction, multiplication and division is known as arithmetic circuit. Example of arithmetic circuits are half adder, half subtractor, full adder, full subtractor. I wish to share some more information regarding the combinational logic circuits now. The logic circuit that can be constructed by using AND or NOT only are known as combinational logic circuit. Already I have told to you, the logic circuits that can be constructed by using AND or and NOT gates only are known as combinational logic circuits. These circuits are greatly employed in various digital systems to implement various combinational logic functions. These circuits are greatly employed in various digital systems to implement various combinational logic functions. This combinational logic has no memory, hence present outputs depends only on the present input. Present output depends only on the present input. Here we are using arithmetic circuits also. They are used to perform arithmetic operations such as addition, subtraction, multiplication and division. In digital computer system, these circuits are used to design arithmetic logic unit ALU. Already we know that in a computer system there are three parts: monitor, CPU and CU. CPU means central processing units and CU is control unit. In CPU there exists a processor, it controls the arithmetic operations what we want to do. Next, we have encountered multiplexer also here. Multiplexers are used as the data selectors. Consists of data select inputs that permit digital data in any one of the many inputs to be switched into the single output line. Now decoder means it is a circuit which is to enable input, can also function as a demultiplexer. It converts the binary data into decimal, hexadecimal and octal, etc. Next, demultiplexer. Demultiplexer is a logic circuit that receives the information on a single line and sends the data on several output lines. It receives the data on single line and transmits the data on several output lines. Multiplexer is a data selector. Okay, it takes the more number of data as a input, that is from several input lines, and sends the data in only one single output line. Main difference between multiplexer and demultiplexer. Multiplexer means many inputs and single output. Demultiplexer means single input and many outputs. Combinational logic circuit deals with the techniques of combining the basic gates that are intended to perform desired function. Examples of such combinational logic circuits are adders, subtractors, multiplexers, demultiplexers, decoders, encoders, dividers, display drivers, keyboard encoders, display drivers, keyboard encoders. Logic circuit without feedback from output to the input constructed from a functionally complete gate set are said to be combinational. Here combinational logic circuit also have many inputs and many outputs. If suppose input is 2, output may be 2. Input 3, output may be 2. Likewise, half adder and full adder. Likewise, half adder and full adder. An introduction to the arithmetic circuit I am going to inform you. The logic circuits are digitally performing the arithmetic operations such as addition, multiplication, subtraction and division are known as arithmetic circuits. This topic leads to the some logic circuits that can add and subtract. They are together to form adder and subtractors. Here they wish to perform the addition and subtraction, and in digital technology the circuits are used in the design of arithmetic logic units. They are ALUs. Arithmetic logic units, ALUs. This is the introduction regarding the combinational logic circuit. Main important thing is definition of combinational logic circuit. It is a circuit in which present output depends upon the present input. Examples of combinational logic circuits are adders, subtractors, multiplexers, demultiplexers, encoders, decoders. Okay, first one, adders. Adders are of two types, half adder, full adder. Half adder has two inputs and two outputs. Here two bits are added together to get two outputs, sum and carry. Full adder has three inputs and two outputs. In these three bits are added together to form two outputs, sum and carry. Next, decoder. Decoder is a circuit which convert binary data into many forms like hexadecimal, octal and decimal, etc. Next, multiplexer. Multiplexer is a device which is used to transmit data, takes the data in several input lines and sends the data in only one single output line. It is a data selector. Demultiplexer. Demultiplexer is a device. It transmits the data in one single input line and it receives the data in one single input line and transmits the data in several output lines. Okay. Next, last one, arithmetic unit. The circuit which performs the arithmetic operations such as addition, subtraction, multiplication, division is known as arithmetic circuit. Now we are going for the half adder explanation. By viewing this diagram, we can inform that inputs AB and outputs sum carry. Inputs of half adder is 2, that is A and B. Outputs of half adder is 2, they are sum and carry. It is the block diagram of the half adder. Please make a note of it. Block diagram of half adder. Block diagram of half adder. Okay. Now function of half adder. See here, we already know that half adder is a combinational logic circuit. It has two inputs and two outputs. It performs 2-bit binary addition and produces the output sum and carry. Binary addition means 0 plus 0 0, 0 plus 1 1, 1 plus 0 1, 1 plus 1 1 0. Once again repeating, half adder is a combinational logic circuit. It has two inputs and two outputs. It performs 2-bit operations, 2-bit addition and produces the output sum and carry. Binary addition, we know that the rules of binary addition are 0 plus 0 0, 0 plus 1 1, 1 plus 0 1, 1 plus 1 1 0. Next, here I am giving the truth table of the half adder. One minute. Here I have taken the two input variables. That means we will get 4 inputs here. 2 power 2, that equal to 4. 0 0 it is 0. 0 1 it is 1. 1 0 it is 2. 1 1 it is 3. 0 1 2 3. 0 0 0. 0 1 1. 1 0 2 1 1 3. Here we are getting the carry 0 0 0 1. That means carry means, by viewing this output we can judge that carry is a AND gate. Next sum is 0 1 1 0. That means 0 1 1 0 is XOR gate. That means half adder is a combination of AND gate and XOR gate. By viewing this truth table we can notice that, we can judge that half adder is a combination of XOR gate and AND gate. Please make a note of the truth table of half adder. Truth table of half adder. Truth table of half adder. Boolean expression for sum and carry of half adder is carry AB, end operation, and sum A XOR B, that equal to A B bar plus A bar B. Carry is AB, end operation, and sum A XOR B, that equal to A B bar plus A bar B. A B bar plus A bar B. Please write this one also. Boolean expression for sum and output, sum and carry of half adder. For carry it is AND gate. I have already mentioned in previous slide. AND gate AB, and sum it is A XOR B, that is called AB bar plus A bar B. That is XOR gate. Sum is XOR gate. Next one. Now we are going for the XOR gate. It has two or more inputs and only single output. Its output is high when the inputs are different. Here I have given the XOR gate diagram also. It is the representation of XOR gate, symbolic representation. Inputs are 2 and only one output Y. AB is the input and Y equal to AB bar plus A bar B. Next, the truth table representation also given. Already we know that inputs 2 means 4 inputs are there. That is A XOR B, that is 0 1 1 0. We can write it as for 0 0 AB, 0 1 AB bar, 1 0 A bar B, 1 1 A bar B bar. So output for one values is 1 1, that is AB bar plus A bar B. Next, function of XOR gate in half adder. The Boolean expression of XOR is same as the sum of the output of half adder. The Boolean expression of XOR gate is same as the sum of the output of half adder. It performs the 2-bit binary addition. So the output XOR gate is the sum of the half adders. The output XOR gate is the sum of the half adder. AND gate. Its output is high if all its inputs are high. AND gate means its output is high if all the inputs are high. See, diagrammatic representation of AND gate I have given here. It has 2 inputs and only one single output. AB are 2 inputs and output Y equal to AB. Its condition is output is high when all the inputs are high. Here I have given the truth table format of that. For 0, 0 it is 0, 0, 1 it is 0, 1, 0 it is 0, 1, 1 it is 1. Output is high if all the inputs are high. AB is the input and output is Y equal to AB. When both the inputs are high, output will be high. Function of AND gate in half adder. Here the Boolean expression of AND is same as the carry output of half adder. Hence AND gate produces carry output in half adder. Once again repeating, the Boolean expression of AND is same as the carry output of half adder. The Boolean expression of AND is same as the carry output of half adder. Hence AND gate produces carry output. Okay. Now I am giving the half adder using XOR and AND gates. Please note this diagram. Half adder using XOR and AND gates. Please make a note of it. Most important diagram it is. Half adder using XOR and AND gates. See, for sum, sum is taken out from XOR gate and carry is taken out from AND gate. Inputs are AB. Sum equal to A B bar plus A bar B, that equal to A XOR B, carry equal to AB. Here I have given the input truth table also. Once again, please make a note of it. Truth table of half adder. Inputs AB, outputs sum and carry. 0, 0 means sum 0, carry 0. 0, 1 means carry 0, sum 1. 1, 0 means carry 0, sum 1. Input 1, 1 means carry 1, sum 0. Now operation of half adder circuit. Here see, we are taking the cases here. Case 1, A equal to 0 and B equal to 0. Here we are giving the inputs that 0, 0. For XOR gate, 0, 0 will be sum equal to 0. For AND gate, carry is giving the output that 0. So, if A equal to 0, B equal to 0, sum is equal to 0 and carry equal to 0. And sum is 0 and carry is 0. Okay, please make this one operation of half adder circuit. If A equal to 0 and B equal to 0, sum is equal to 0 and carry is equal to 0. Next one, case 2. Here A equal to 0 and B equal to 1. We are giving the 0, 1 to the inputs of the XOR and NOR gate. Here for XOR gate it is equal to 1 and for AND gate it is equal to 0. For input A and B, XOR gate is equal to 1. Input AND gate 0, 1, we get the output 0. Hence sum is 1 and carry is 0. Next, case 3. A equal to 1 and B equal to 0. Here we are giving the inputs 1 0 to the XOR gate and AND gate. When we give 1 0 to the XOR gate, we get the output 1, and 1 0 to the AND gate, we get the output 0. Hence, sum is 1 and carry is 0. Okay, all of you writing in your notebook. Most important thing it is. Fourth one. Operation of half adder circuit. Case 4. A equal to 1 and B equal to 1. Here, for XOR gate, we are giving the inputs 1 1. We get the output for XOR gate is 0. For AND gate is equal to 1. When both the inputs are 1, for XOR gate is equal to 0, for AND gate is equal to 1. Hence, sum is equal to 0 and carry equal to 1. By summarizing all the 4 cases, we get that if A equal to 0 and B equal to 0, sum is equal to 0 and carry equal to 0. If A equal to 0 and B equal to 1, sum is equal to 1 and carry equal to 0. If A equal to 1 and B equal to 0, sum is equal to 1 and carry equal to 0. If A equal to 1 and B equal to 1, sum is equal to 0, carry is equal to 1. Okay, this is the summarizing concept of half adder circuit. Once again repeating the operation of half adder circuit. Once again, please have a look of it. A logic circuit for the addition of two 1-bit binary numbers is known as half adder. A logic circuit for the addition of two 1-bit binary numbers is known as half adder. The function of this circuit is to add two binary digits producing the sum and carry. The function of this circuit is to add two binary digits producing a sum and carry. The logic circuit for this half adder is shown in figure. The carry output is produced with an AND gate with A and B on the inputs, and sum output is produced with an exclusive OR gate. The logic circuit of the half adder is shown in figure. The carry output is produced with the AND gate, and sum output is produced with the XOR gate. That means here we are taking the inputs to AB and outputs to sum carry. Now we are going to the logic operation of the half adder and is expressed in truth table as shown in the above slides. The expressions are derived from the sum and carry outputs as functions of the inputs. Now the carry output is 1 only when both A and B are 1s. Therefore, carry output can be expressed as end of the input variables. Then carry output can be expressed as one of the input variables. C equal to AB, that is carry equal to AB. Notice that sum output is 1 only if input variables are not equal. Therefore, sum can be expressed as exclusive OR gate of the two variables. Sum is equal to 1 when both the input variables are not equal. Therefore, sum can be expressed as a exclusive OR gate. So, S equal to, that is sum equal to S equal to A XOR B, that equal to A bar B plus AB bar. A bar B plus AB bar. The logic symbol for the half adder is also shown figure, which accepts two binary digits on its inputs and produces two binary digits on its output, that is a sum bit S, a carry bit C. Notice that binary operation involved in half adder is the arithmetic addition, not the logical or Boolean algebra addition. Note it, It is the operation of the half adder. Going for summary. In this period, we have discussed about the combinational logic circuit, definition, examples of combinational logic circuits, that examples, definitions, and overview of the logic circuit of half adder, truth table of half adder, operation of half adder. These are the topics so far covered in this session. Now going for quiz. In a combinational logic circuits, output depends on the present inputs only. Answer is A. Present inputs only. Half adder is a circuit switch. Half adder is a circuit which A. adds only 2 bits, B. adds only 3 bits, C. adds any number of bits, D. none of the above. Half adder is a circuit which adds only 2 bits. It is A. Adds only 2 bits. Half adder can be constructed using basic gates, XOR gates and AND gates, universal gates, all the above. All the above is the answer. We can construct half adder with basic gates, XOR and OR gates, XOR and AND gates, and universal gates also. Fourth one. What is the sum output of half adder when A equal to 0 and B equal to 1? For A equal to 0 and B equal to 1, sum value is equal to 1. Answer is B. I have given some frequent asked questions here. What is the function of half adder? What is a combinational logic circuit? Draw the truth table of half adder. And briefly explain the circuit diagram of half adder using XOR gate and AND gate. Here I have given some assignment questions. Please write down this question and complete the assignment in your notebook. Construct half adder using basic gates and explain its operation. Please make a note of it. Construct half adder using basic gates and explain its operation. Once again repeating the combinational logic circuit, its output depends only on present inputs. Logic gates are the basic building blocks of combinational logic circuits. Okay. Next examples are half adder, full adder, multiplexer and decoder. Half adder, full adder, multiplexer, decoder. Next, half adder definition. It has 2 inputs and 2 outputs. It has 2 bits, that is binary digits, and produces sum and carry. It has 2 bits, binary digits, and produces sum and carry. Next, full adder. It has 3 bits and 2 outputs. It adds 3 bits and produces sum and carry outputs. It adds 3 bits and produces sum and carry outputs. Multiplexer. A digital circuit that sends data from any one of the many lines to a single output line. Any circuit that sends the data from any one of many lines on a single line, different data will be present on the multiple inputs. Different data may be present on the multiple inputs. Out of these multiple inputs, one is selected and sends to the output line. Now decoder. Decoder is a device which converts binary data into other forms such as decimal, hexadecimal and octal letters, etc. Next, arithmetic circuit. The circuit which performs the arithmetic operations like addition, subtraction, etc. Division, multiplication also. Example, half adder, half subtractor, full adder, full subtractor. These are the arithmetic circuits. Now half adder. Half adder has 2 inputs and 2 outputs. Inputs are AB, outputs are sum carry. Please draw the diagram of block diagram If you draw it, please leave it. If anyone not drawn, please draw this diagram or take a pic of this diagram. Okay. Next, function of half adder. It is a combinational logic circuits. It has two inputs and two outputs. It performs 2-bit addition and produces the sum and carry. It performs 2-bit binary addition and produces sum and carry. Binary addition is 0 plus 0 equal 0, 0 plus 1 equal to 1, 1 plus 0 equal to 1, 1 plus 1 equal to 1, 0. Next, truth table of half adder. Here inputs are AB, outputs are carry sum. Input 0 0 means carry 0 sum 0. Input 0 1 means carry 0 sum 1. Inputs 1 0 means carry 0 sum 1. Inputs 1 1 means carry 1 sum 0. Carry 1 sum 0. Boolean expression for sum and carry of half adder. Boolean expression for sum and carry of half adder. Carry means AND gate, that is A into B. Sum means XOR gate, that is A XOR B, that equal to A into B bar plus A bar into B. Now XOR gate. It has two or more inputs and single output. Two or more inputs and single output. Its output is high when the inputs are different. Its output is high when the inputs are different. Here XOR gate has two inputs and only one single output. Inputs are AB and output Y equal to AB bar plus A bar B. Here it has given the truth table also. Input 0 0 means output 0. Input 0 1 means output 1. Input 1 0 means output 1. Input 1 1 means output 0. Okay. So the output is 0 1 1 0. Now function of XOR gate in half adder. That is, the Boolean expression of XOR gate is same as the sum of the output of half adder. It performs the 2-bit binary addition. The output XOR gate is a sum of half adder. The output XOR gate is a sum of half adder. Now AND gate. The output is high if all the inputs are high. Output is high if all the inputs are high. Inputs AB, output Y equal to AB. Here the truth table also given. Input 0 0 means output 0. Input 0 1 means output 0. Input 1 0 means output 0. Input 1 1 means output 1. It is the AND gate truth table. The function of AND gate in half adder. Boolean expression of AND is same as the carry output of half adder. Hence AND gate produce carry output. Hence AND gate produce carry output. It is the half adder using XOR and AND gate. It is the half adder using XOR and AND gates. XOR and AND gates. Please note the diagram, most important one. It may be asked in 3 marks question that half adder, draw the diagram for the half adder using XOR and AND gates. There exists the truth table of here. Already we have accomplished this one. Operation of half adder circuit. If A equal to 0 and B equal to 0, we get the sum equal to 0 and out, so carry equal to 0. If A equal to 1, 0 and B equal to 1, sum equal to 1 and carry equal to 0. If A equal to 1 and B equal to 0, sum equal to 1 and carry equal to 0. If A equal to 1 and B equal to 1, sum is equal to 0 and carry equal to 1. Summary. Already we have discussed this one. Quiz is also more important. Once again repeating the quiz. In a combinational logic circuit, output depends on the present inputs only. A. Second one, half adder is a circuit which adds only 2 bits. It is also A. Third one, half adder can be constructed using basic gates, XOR and AND gates, universal gates also. Next, fourth one, what is the sum output of half adder when A equal to 0 and B equal to 1? It is equal to 1. B. Here I have given the frequently asked question as well as an assignment question also given. Please make a note of it and complete it In up to next session, construct half adder using basic gates and explain its operation. Construct half adder using basic gates and explain its operation. Thank you. Thank you for hearing my class. Thank you for this session. Thank you so much.